మీరందరికీ చెప్తారా డైరెక్ట్గా వాళ్ళ వీడియోస్ చేస్తారా
వీడియోస్ కూడా 11:15
ఇప్పుడు కాదా
స్టార్ట్ చేసి
స్పీడ్ టెస్ట్ చేసా సార్ చేసి చూసా సార్ స్పీడ్ టెస్ట్
You removed all of the.
నో సార్ దట్ ఈస్ దేర్ సార్ అవు సార్
ఏదో ఒకటి చేస్తాను. I'll do something.
I thought it was
Sure. Set it up. Is it done?
Yeah, it is live, sir.
All right. So do you want to send this to everybody? The link.
I will send. Start.
How do you get the link?
YouTube.
Okay, sure. But good morning, everyone. Regret the delay. I think there are some certain things have to be set up, so some videos had to be configured. That's how this delay. I think since we have not communicated about this link to others, we are still small group. We will take a couple of minutes time before we start. Okay, good morning everyone. I hope yesterday content was useful. Today we will look at a quick recap of neural networks, how these network models work, and then we will also look at CNN. Then we will execute two different applications today. Yesterday one of the codes between TensorFlow 1 and 2, it wasn't working. Today we will I have got that refined. Also based on the request yesterday, today I am going to share line wise code, and we will understand that and execute, and we will do it together here on the system so that you will also get a feel. Later we will share with you that code so that you could run on your machines. We will conclude today's session with an application, a very interesting application during this COVID situation, how at the time of sanitization, how we can capture the people who have been asked to quarantine, and in case if they are anywhere outside and they go through these sanitization tunnels, then it will communicate saying the person is supposed to be in quarantine. So we will look at how the face recognition is being used in that application today. Alright, I will also improve the audio a bit. Good morning everyone. I see the messages as many of them joined today. All right. Yesterday's PPT along with. some pointers. Okay. We will use sort of a whiteboard. This I'm using it more like a whiteboard so that this definitely will be clear to you. You will be able to see the screen. Alright. So the network models, when irrespective of whether they are network models or typical machine learning models, we said the machine learning is involves three steps, and step one is about pattern identification, and step two is about error determination, and step three is about error rectification. So in the pattern identification, we have different methods. If the input variables x1 to x1, xn, let's say there are so many input variables, and then the value that we want to target variable or output variable is y. So there can be a linear relationship between the input variable and output variable, where when there is a linear relationship, we know we use y is equal to mx plus c, a linear equation we draw. This is pattern identification. If the y is a binary, then we will use some sort of a sigmoid function, y is equal to 1 by 1 plus e power minus x. So essentially we are looking at the pattern between input and output. So and the pattern is determined using a set of parameters that we call them as weights and bias. So these are the parameters. Initially we will make some assumption and have some unified or random initializers of 0 or 1 values to them. Then we will run the model using the equation or any method. Then we will compare the error. What is the error in terms of what is the ground truth value and what is the predicted value, y minus y hat I would like to call. And here there are different methods of again error determination, the way we have different methods in pattern identification. So these methods include sum of square of errors, the other methods that we have, a mean square error we have, and then we also have cross entropy that we discussed yesterday. Cross entropy, both for categorical and the binary cross entropy is available for classification purpose. In real world, you see more of classification data, whether it is a dog or cat, whose photo is this, whose image is this, and so on. Many of them are more classification in nature. There are continuous output values also, like what is the likely profit of the company and so on. Now, once you determine the error using one of these methods, you attempt to rectify the error. So to rectify the error, we have to somehow bring this y hat, the predicted value, close to the ground truth value. So the way we can do is make modifications to these parameters w and b. So we will make some small adjustment. We discussed about gradient descent as a method. You have very many different approximation methods you have to bring down or to modify these parameters so that the error will be as less as possible, so come closer to 0. So one of the methods that we discussed is gradient descent. When you introduce record wise or object wise, if you are doing, then we call it as stochastic gradient descent model. The more powerful model here is Adam. This method is effectively being able to rectify the error faster. So the y minus y hat. So here a common one is cross entropy. This error determination, there are many terms here. Cost function it is called, error function it is called, objective function it is called. So these are different terms that are used here. And pattern identification, there are innumerable methods. If you look at machine learning, you have linear, logistic to support vector machine, ensembling models, decision trees, ADA boost, and so on and so forth here. Now, the error rectification, again, there are multiple. We have looked at gradient descent. Now, in a network model, what happens is a sort of a magic compared to the machine learning models, the standard machine learning models. In standard machine learning models, the number of parameters W1 to Wn is dependent on number of input values, that is x1 to xn. How many other input values that you have, only those many weights are possible in a machine learning. Of course, you can have a principal component analysis. Some of you are faculty in computer science engineering. You would be familiar with this. We call this as unsupervised learning, where if you have 1000 x1 to x 1000 parameters, and if you think that these are very vast and you want to transform it, you can do some sort of a transformation of it. So you don't know the output variable, so we call it as unsupervised learning, and transform into whichever wherever you have highest information gain. So you retain only those 50 to 60 or 50 to 100 input variables which have high reference. So in this case again you will only have only these many weights W1 to W100 or so. Now in a network model it happens like the magical way is that if you have an input values, let's say here x1 to xn, and then what you are predicting is, let's say there are two output values. Now normally the weights are directly connected, the each input values are directly connected to the output. Let's say all are connected to this, and you could also have and let's say this is yes or no kind of thing depending on the value that we get. It's for now we will keep it as simpler. Alright, so now here in this case, this is a typical machine learning model where it is connected directly. In network models, you create hidden layers. So you can create one hidden layer here and say the hidden layer could have maybe half of the total number of input variables. So it is x n by 2 number of variables you can keep. This is a rough estimate, and I found that in this method we are getting superior results and computationally efficient. Now what happens is in this hidden layer, suddenly each cell becomes an output kind of thing, and it is fully connected. So all the input variables are connected to every cell in the hidden layer. So in the process, what also happened is, so for every connection you have one weight, one parameter attached to it. And at every hidden layer you have one bias, of course, available. One bias is available. Now, therefore, if you have more hidden layers, the number of parameters that you are going to get is many. So the entire learning of pattern identification from a training data set is nothing but those set of parameters that you have, and so on and so forth. So in the process, you can have as many as the parameters that you want, and it is not really dependent on your input variables. So I would say that it tends to be infinite. You can have infinite number of parameters based on the number of hidden layers that you create. So we also said that to avoid overfitting of data, you could drop certain connections, and you say that I will drop out probably X number, so 20% of the connections I will drop out. I will drop out this connection, I will drop out this connection, and maybe I will drop this connection. So something like this we say, and it across you can do. So 20% to drop out you can always, any percent, 20%, 30%. I will show you an example where I'm doing 50% to drop out too. So we can do that, and this is called fully connected layer. When you have more than 4 hidden layers, then it becomes a deep neural network. So all these cells, we also said these are more like biological neurons, where there are two things that are happening. One is the input values that are there. It is becoming sigma or dot product, which you will see later. And then once you have all of this added, as good as the linearity, that is y is equal to mx plus c. Mx is nothing but you have x1 to xn, all are getting added along with the weight. And sometimes you can have a linear output. However, normally I discuss saying that you bring non-linearity into it and rectified linear unit. Instead of y is equal to mx plus c, which is y being minus infinity to infinity, you will transform this to y being 0 to infinity, so that any negative value which is there in these either weights or the x values, those negative values will not affect the overall learning. So the output of rectified linear unit, the same linear one, it is slightly rectified to bring the y to 0 to infinity. What it means is, if x is less than or equal to 0, y is equal to 0, and x is greater than 0, then y is equal to x. So it is as simple as this. So here you can see gets multiplied. This is the rectified linear unit we discussed. We also discussed these activation functions, or a sort of pattern identification, but every level you have this pattern identification happening in these neurons. So two other activation functions that we discussed yesterday was one, the sigmoid function, which will bring the y value to 0 to 1, it quashes. So it is a binomial classification. You can use it across all the neurons. However, if the terminal neuron or output layer, if you have a multi-class classification, then you need to use a multinomial regression model. So multinomial classification model, that is softmax, is available. So you could use softmax. Then we discussed that this entire process of computing becomes the forward pass happens. Now error rectification requires weights being changed across the layers. So across different layers you have to change the weights. So this process is called backward pass or backward propagation. You propagate or broadcast the change in the error, the change in the value that you got to make. That error has to be reduced. So you have to go and publish everywhere, please reduce the error, please reduce the error, by making some change in the weights. So this is a neural network model. So from there, yesterday we moved to, there is a convolution method which is very powerful and effectively used since 2012. Since 2012, ImageNet used to be a competition for several years. Subsequently, it was dropped after Kaggle has come in. So, in the ImageNet, where the images are posted and people are asked to submit their algorithms, and the best algorithm or a most efficient algorithm was built on CNN. So these researchers, one of them is Alex, yes, I do not recall full form now. So he used this AlexNet where it is the inspiration of convolution. While convolution has been there since 90s, particularly it was used, I think it was in Bell Laboratories or so, where for the zip code identification in the postal, so this was used. Now convolution started there. Now essentially what happens in the convolution is, while it uses network model, which is a fully connected layer, before that it does some bit of processing to retain the two-dimensional image. In the past, if it is a two-dimensional image, all these, so we discussed the images, only the pixels are looked at and the pixel values are 0 to 255 if it is a gray or black and white scale, and if it is a color scale, then you have three channels which are RGB channels. So every channel will have again 0 to 255 brightness. We will also talk about just after this how you process this too. Now earlier all of these pixels would have become flat one after the other as input variables. So every pixel is an x1, x2, xn. So if it is a, let's say 32 by 32, it is roughly 30 by 30, I can say 900. Let me look at. So 1024. So 32 by 32, we will have 1024 input variables. So x is x1 to x1024. So in the regular network model, all of them would have become flat, and then it would have looked at what is the pixel brightness across different images. Across, this is object 1 and another is object 2 and so on. All those objects it would have seen. In a convolution model, it retains this two-dimensional spectrum of the input data. So what it says is it will process the image in as-is form, and let's say this is the image. I will again recast the image here so that we can do a fully convolved data. Here we will use, now the weights are not going to be individual, instead we will use a weight matrix. A matrix of possibly, we can have different combinations, let's say 3 by 3 we have chosen. So the weight matrix is 3 by 3, and these are popularly known as kernels or filters. So kernels, so let's say, and this is the input image that you have. Now what happens is this kernel is slid through these things in this form, and then we use a dot product of it to get the resultant value. So dot product, you are familiar that sigma value. However, in the matrix, every value, say here the 9 blocks here, get each block element wise operation will happen, multiplication, and all of them get added to get the first value here. Now you get the feature extraction map. So this dot product is there. Now once you have this, we also spoke about this feature extraction map that we get is you have a sort of a formula that you can use for this feature extraction map, which is input minus input size minus the kernel that we use plus 2 times of padded, we'll talk about the padded right away, divided by number of strides plus 1. So this equation will give you the size of this feature extraction map. Now, padding that we are talking about is in case you have the edges with very important information, so to retain that information, make sure that it is not lost, you can create a padding. So when you create padding, we know that null values where there is no brightness at all, which is black in color, is 0. So you fill this padded with all zeros so that you are not adding any additional data into the image, and yet you will have the edges captured well. So you can have two pads, so two padded circles which is 0, 0, 0. So since the both sides you add, so it is becomes 1, here I am saying 2p, you will get it. Another thing is the stride. Stride is at what rate the transition happens from one to the other. So if you are just transitioning by one column, then you will have stride is equal to 1. But if you are jumping by 2 every time, then stride is equal to, you can have stride is equal to 3 depending on what is the density of the image that you have chosen. Now this is how we have stride, we have padding done, we have kernel size we have done. So typically here you will not have just one kernel, one filter, you will have many filter. I will probably put it in this manner so that we can see. So you will have multiple filters. So every filter will offer you one feature extraction map. So while your input is only one, so but the filters that you are going to get is based on the filter, you will have many more data points that you will get. Now, so the resultant, let's say in this case you have 32 by 32, we will retain. What will happen if you don't have any padding? Padding is equal to same and stride is equal to 1. So stride is equal to 1, and let's say you have used the filters, 10 different filters you used of 3 by 3 size. The number of feature extraction maps you can imagine now. So what will happen to the feature extraction map is, so you have this 32 minus 3 plus 32 minus 3 is 29 plus 1 is 30. So you will have 30 by 30 as a feature extraction map. However, there are 10 such feature extraction maps that you will now get it. So 10 such feature extraction maps. So these 10 feature extraction maps, further we also discussed that you can use then these feature extraction maps that get convolved subsequently. So this is the line probably the right. Yeah, so these are now 10. So these 10 feature extraction maps go through some sort of the activation function, and I said ReLU is the preferred one. So you will keep a ReLU here, which is a sort of like this. I will keep this is normally for sigmoid. So ReLU, it gets activated where the numbers are transformed. Then the output that you get, this output is pooled. So in the pooling, let's say we are using a pooling of 2 by 2, where you are essentially saying is you take a 2 by 2 matrix, and then whichever is the highest, max pool is one model. Of course, average pool is another model. I prefer to use max pool, and it is yielding better results. So in max pool, let's say here it is 30 by 30, you will take every 2 by 2 and convert that into a single value. Now again, you will also take stride. Let's say you have taken the filter as 2 by 2 and then stride at 2 here, which means you skip 2, 2, then you will end up getting 30 becomes 15 size max pool. Now you have a 15 size, 15 by 15 max pooled output from the feature extraction map, and we have 15 such things. So you will again get all the 15 here, and these 15 now, these are the max pooled output. Fully flat. So when we say 15 by 15 into 10, essentially you are going to get 2250. The number is correct. 15 into 15. Yeah, it is 2250. So we have now these from here, if you are making a fully flat layer, this will turn into 2250 neurons, or not neurons because there is no processing here. These are 2250 input cells that we are getting. So you have flattened these input cells, And from here again you will use network model. You can use some hidden layers, and then you can go with output layer if it is about image of yes or no kind of thing, is this a dog or not kind of, or dog or cat kind of thing, then you have one output saying if it is yes, some value of 1, and if it is no, then 0. So you will, this classification you do the one hot encoding. So we have this utilities library within the Keras where it will convert all the categorical single one dimensional vector you will have here too. But if you have 10 different classes, it will get 10 different one dimensional vector values 1, 2, 3, 4. Let's say 0 to 9, if it gives, then it converts into a 10 dimensional matrix. So you will get a matrix of the values because it is all has to be one hot encoded. So 1 0 0 0 0 1 0 0. It is encoded values into more zeros and 1. Now, this is the broad process that we have seen yesterday in CNN. Right now, we are going to look at an application for it. I will so the way we will do today is around once we go through this application around 11:15 we will take a break. 5 minutes break we will take. As and when we complete, then post the break I will look at the questions and try and answer them, and then we will look at the application part. So where we have codentious.ai, we say Shivang, one of the faculty who is going to take these sessions for in future. He will his vision of how face recognition can be done in multiple points. I will share that application. All right. Now, hoping that this has some clarity on how it is done, I will bring one more element. Imagine this is not a grayscale, but it is an RGB. Is your filters also will not be just 3 by 3 in an RGB in a 3 filters. Let's say you are using 3 by 3. Three such filters become one set is each of them will result in a separate feature extraction. So you will have three feature extraction into 10. You will then have more. So here also you will have 10 into 3, 30, and 30 into 25, which is 600. Those input values, that is the additional. Each one will have between 0 to 255. So therefore, the kernel size becomes three-dimensional now, and then the resultant also value will significantly increase the number of input values. In reality, you will see more of color images only. So I will come back to before going. I use this terminal. This is an operating system. So this is again my terminal. I have Conda Activate AI training where I created a virtual machine where entire data is available. I'm now typing Jupyter Notebook. Suggested us to use Anaconda, and you could open Jupyter Notebook from there, or from here also you can open the Jupyter Notebook. So I'm going, we will get to see our root folder, root drive here. So I'm going to access the file. And yesterday we were looking at MNIST, which is talking about numbers 0 to 9, numbers which are handwritten digits. So yesterday when we attempted to execute it, for some reason it didn't work, but later when I had tried, it worked. I will make sure, is this the file I've done? Yeah. Now, in this, probably we'll share more about this. More importantly, there is a German traffic signals one. We will go in greater details, but I want to make sure that yesterday we stopped it somewhere in between. So we will run this file. So here CV2 is to read an image. It is useful. Matplot library and Seaborn both are for plotting visualization purpose you use. Now, NumPy is the library which is the key. NumPy and Pandas I spoke about. NumPy has the linear algebra, all the computations available. Now in the Keras, so there are two APIs or libraries that we use for network models. One is TensorFlow, which is of Google. So it acts like it is an API with all the network models code is already pre-written with the hyperparameters. So we can just call their functions and methods and execute. Now, we also have a new another API called Keras, which acts like an interface, which further simplifies this TensorFlow code. In just a few lines, 3 lines, 4 lines, 5 lines, we can build the entire model. So you will see how it is available. So sequential, because our models are sequential, we mentioned, they have another method, keras.models has model. This is where you can compile the data, you can fit the model, you can compile the model using the loss and error determination and error rectification methods. You also have how to provide the input or the input parameters. Is it one dimension or two dimension? We can provide. So then you have Keras probably more than sharing here. I will talk about these libraries in the next example where I have also broken that down into pieces. Then we had, so I'll quickly run this just to make sure this works, but we will go and review the next one. These are all the libraries that are relevant. So you will see automatically that flow is running in the back end. So executing this code so that you also been able to see. Now this is X test, Y train and Y test. X train is the training data set of input values. Y train is the training data set of output value. So output values are 0 to 9 and X are there are 60,000 records available. Now similarly, X test and Y test belong to test data set which I spoke about. We will take you through the typical steps in the machine learning steps. You have the first one is you have to read the data, understand what the data is, and second step is this is so we call it as read the data. Even before that, you have to understand business problem, recognize what is the inspiration, what are the key parameters that are relevant, etc. Once you get the data, you have to pre-process the data. So you have to look at are there any outliers, categorical values, convert them. Is there any imputation that needs to be done? Imputation is you have some blanks, lot of blanks, so then it cannot handle. So pre-process the data. All of this, you basically prepare everything into those zeros and ones for the machine to understand. So if it is images, then pixel. If it is text, then you will create some sort of vector representation of the text words, etc. And there are very different methods for it and to do it, engrams and so on. Maybe in the next faculty development program that Blsckbuck arranges and Anurag University arranges, maybe we can look at the text modeling also. And there are two different very powerful methods within the network models for text. One is recurrent networks, second is transformer based models. So recurrent networks historically have given a lot of impetus, but I think since 2018 particularly, however since 2015 we have these transformer based models where attention is what is important for them. They don't need to worry about the recurrence of it. So attention based a lot of respect, and today the most powerful models are attention based models only in the text analysis. So you see all those chatbots, etc. Or if it is an intelligent bot, it is able to generate text, then you can assume most likely that is attention based model that is working. All right. Once you pre-process the data, then you will get into model development. That is where we saw the pattern identification. So pattern identification, error determination, error rectification, all three steps that you follow. Once you have done this here, then you will evaluate the model. So is it working well on my test data or not? So there are different evaluation methods. If you have attended the first FDP 2 weeks ago, we spoke about confusion matrix as one method of evaluation, and where it is not just looking at accuracy, it also looks at recall and sensitivity. So true positives and false positives, and true negatives and false negatives. So we spoke about true positives, true negatives, and false positives and false negatives. So through this you have the F1 score that can be for the categorical values, then the classification values, you have evaluation. Once you evaluate the model, you have now you have the parameters till you get better. So that is an iterative process. Then you will take your weights all the parameters that you have, weights and bias, and take it as an output, and it is available for real world testing purpose. So when you deploy this, probably I'll speak more about it when we are doing the application. You got to have an interface. The model by itself can't be accessed. It's nothing but a piece of code. So this piece of code or algorithm has to be wrapped into some form of a REST API. We call it an application program interface. So it has to be wrapped so that it has these. If you are going to access through a web interface, then you need to have the protocol. So hypertext transfer protocol is what we will talk about. So you got to have those protocols, request and receive, post and get. It should allow. And if you are going to host it on a cloud or anywhere, then you need a box kind of container so that it is also OS ready and all the dependencies are neat. So nowadays the most popular containers are Kubernetes is one. Docker has been the last few years doing extremely well, where you don't need to have it's just an image with these dependencies available and your code which is in it. So now it can be nowadays microservice architecture is also gaining a lot of popularity. Irrespective, all your services all will be on the server side, and you will create a web interface, nice web application development you will do and access, or a mobile application also you can do and access your model. If it is about face recognition authentication, it will make a request to go to this place and come back. All right, these are the steps involved in the machine learning at a high level. We will now. So once I load the data here and split the data set, here we can also, once we process the data set, we also split the data set into some for training purpose, some for testing purpose, so that you can use training is in the model, testing is in the evaluation. So you can use this data. This is what that step is about. I'll make sure I won't run. So mnist.load data, because mnist is a file already available in Keras. That's how. Here in the next step, I am changing the shape of it, making sure it is all 28 by 28 because and one grayscale images. And then I'm also scaling that down so that computationally, if it is 255 value here, the 255, 100, 150, etc. becomes extremely difficult computationally. Instead, you scale that down to smaller value divided by 255. If you do of any value, then the value becomes from 0 to 255 will get shrunk to 0 to 1. So this computationally is efficient. Yesterday one of the questions was, why should I scale it down? Will it work even without it? Only thing is that computation benefit. Now can also check the shape of it, which gives me number of records or number of objects that are there. What is the number of rows, what is the number of columns in a given thing, and what is the depth. So white train on the other hand is only one value. So it is 60,000. However, the white train is it is an array of single dimensional array of 10 values. So you will notice that this is a list here. Now I have to convert this into a one hot encoded values, zeros and ones. So which is what I do using the utilities here. We'll go to the next exercise there, I will explain, and then post that you will suddenly see the result is appearing is all 0, 1, 0, 0, 0 and so on. Now you look at the shape, you will see that it is not 60,000 comma 60,000 and one column, it is instead 10 columns. You can, for example, check few plots here and see it is all fine, it is all working, that we can see the numbers. Alright, once you do is, now we are ready, let us now get into the model development. Model development, I said first step was you got to define your input. So this is the method which is there in Keras. And then you define my input size is, I have both the breadth and width and height, two of them are there, and it is a only one depth or only one color. Then in the model I'm using, first step is convolution 2D, two-dimensional convolution using 32 filters. Each filter size is 3 by 3 and padding is no padding. It is the same value as the input, and activation is rectified linear unit. So it is a linear unit except for negatives become 0. And input shape, since I am using it for the first time, I will define my input shape is so and so input shape. Now, what is most important is I am going to work on my inputs. This is one way to create in the Keras. Another way is you can keep adding the layers by doing dot add. So I use this method of calling these inputs at the end. So the model now will have inputs getting transformed using this convolution. This is one single line, whatever we spoke about entire yesterday. And then on the model, after you do the activation function, once you create these 32 filters, 3 by 3 kernel size, you will have feature extraction maps. You will get 32 feature extraction maps. Each one, since image size is 28, it is 28 minus 3 plus 1. So 26 size, 32 such ones we will have. So strictly speaking, you have 26 into 26 into 32, you have 216, 21,632 values you have got in that now. And that goes through a max pull. 2D is max pull, happens using 2 by 2. So default stride is equal to 1. So automatically then you have, when the stride is equal to 1, let's say I will do a divide by 32. I think it is 26, right? 26 by 26. So it will be essentially 25. Yeah, it will be 25 by 25. We'll have 25 by 25 into 32, or the total number of values that you have is equal to 625 into 32. So 20,000 values you have in this model now. They are all in 32 different maps. Now in this, what you are doing as a next step, I have done just one convolution. Now I am dropping 20% of them, 0.2. Dropout is another method where you can just drop certain connections to go forward. So 20%, so I will, so 20,000, 4,000 will go, so I will, and then I will flatten. So when I flatten here, flatten is another method. Now you will notice that this model which is here is again appearing, this model. On the top of it, you are dropping out 20% of it. So, and again assigning that to model. Again you are creating another model where this old model is called here flatten it. Now the flattened one has roughly 16,000 neurons, one after the other. So you are then doing dense. Dense is the fully connected layer term where you are converting, you are keeping the hidden layer with 784 values, and activation is ReLU you are using, and you are call this model here. So I will quickly run this because other next example is very powerful and meaningful. Multiple dense layers here that are created. And finally, I compiled compile data here. I kept categorical cross entropy because I have 9 different classes. You'll also notice in the output I have used softmax activation function because again it is a multinomial classification. You'll also see there are 10 here because that is the total number of values. I can even create 9 here and work because one, it is not one hot encoding strictly. I can use all zeros as absence of the value. Once that is done, then I will fit the model. This is where the training is happening. I take X train is my input variables and Y train is my output value, and batch size is 32. While I have so many different values that are there, so inputs are 60,000, but every batch will have only 32. So 60,000 by 32 is what it will run into, divided by 32. 1875 iteration. So 1875 times it goes through for one epoch to be completed. Epochs is equal to 1. Verbose is equal to 1 I kept so that we get this bar here. So otherwise it is not. And white train. And what is the batch size? So if you make it into batches, it is computationally faster. Otherwise, in each epoch, it has to take the entire data. It can take longer time. And I will increase the epochs to maybe 2 epochs or 3 epochs I will use. Let's say I will use 2 epochs and run this model. Now asterisk indicates it. Now you can see live that it is running now, and the values you will see probably jump is 32, 32. It jumps because, or since it is happening at a very fast pace, will not be able to recognize. Total number of times it runs is 1875 with heart. Now you will also see here estimated time of execution, 80 estimated time of completion or so. So more time left is 1 minute 38 seconds. So total time roughly it is taking 2 minutes and it is running on my local CPU itself. The loss is the the error determination, how much of the loss that we have, error has to be near zero. And you will notice that every iteration of this batch size, the error is slowly coming down. Accuracy is the, once we have the error determined, at what with what accuracy it is able to compute, you use a different formula, therefore. So accuracy is also available. So the higher the accuracy, the model is better. The lower the loss is, model is better. That is what we can understand. It will take about a minute more, but if you look at the steps that we have done here as it completes, first is we have imported all the necessary libraries that are there. Next is here itself in Keras you have certain data sets. One of them is MNIST data set. I'm calling the data set, so if you notice keras.datasets is MNIST. And the utilities, keras.utils is the utilities where you can do the one hot encoding possible. Conv 2D, max pool 2D are used for exclusive, are used for convolution purpose of dealing with two-dimensional data. Then you have other layers. These are all layers that you create. So you can add the layer, or you can just do the model, etc. on the right hand side with the braces. That also you can do it. So uh, then what we can also look at here, but probably by now it would have been executed. Let's see. Yeah, since we used two epochs, now you notice here totally it took 133 seconds to complete this, which means slightly over 2 minutes, 2 minutes and 13 seconds it took. And 2 milliseconds it took for each step. And we have done so many steps, I think 1875 steps, because that is what we have done. Let us check what is the exact number. 60,000 were there, but then you said in the batch it is 32 only per batch. So therefore, you have 1875 into 2 milliseconds each one is roughly 300. So 3.7 seconds it is taking, or yeah. So probably per step is giving slightly more data, but we will look at that. Not a problem. So while this is completed, I was also talking to you, sharing more about these keras.layers. So we can add each layer. So dense is used for neural network, ANN. Dropout is can be used both in convolution as well as in ANN, where you don't want the previous connections, all of them to be connected to next. Activation is used to quash or to bring non-linearity. So if you use an activation which is linear unit as an activation, you also have linear unit. So then it will, whatever is the sigma value just comes as the same as an output of that neuron. Flatten is where a two-dimensional data becomes one dimension and becomes vertically, all become as independent variables here. Of course, otherwise also they are independent variables, but flatten will convert a two-dimensional data into one-dimensional data. Sequential, now in TensorFlow 2, we don't need sequential. Model is the key thing that will run this model. Input is where you are providing the input values. All right, so hopefully it is completed, or yeah, it is 4 seconds. Now you see this bar is also getting completed. Yeah, it is done. And this is not bad. In two epochs itself, we have got the loss is 0.48. It is still, there is some loss. Accuracy has moved to 83% is the accuracy. Let's test it on our test data set. We have some test data set and see with what accuracy it can present the this, you see asterisk mark done, and here you go. So the loss is 0.10 and accuracy is 0.97. Extremely good. Maybe it ran more than once on this on the same. So it is extremely good. So we will share with you this data. You can have a look at it. I want to talk about the another data set without losing much time, which is on German traffic signals. This is again available in Kaggle while we made few changes. So if you are running, taking a file from Kaggle, you will have to make sure they are in the TensorFlow 1. You have to convert that into TensorFlow 2 wherever the code has to be modified. So in this case, the library probably I will also show you the data. The images, we have converted all the images into a CSV format. So I'm not taking you through how you can use either IM show, image show is there. There is CV2 is there to convert to read the images and convert that into a number format. This is the file that you see. I will try and make it big. This is the file I have, which is converted into CSV format. I'll just open to show you how the data set is. This data set has 43 different signals, traffic signals like speed, colors, then stop, turn, all these things are there. So the data size is 100 MB, so it will take some time, and I also want to make sure that the speed is good enough because I am running multiple things in parallel on the machine. So is it working well or not? So you have, so we have the model running. I'm opening an Excel sheet which has a 100 MB file, and then I'm also speaking where the live stream does consume time. So quickly, let me look at how many data points are there in this. So you have 785 columns, which is 28 by 28, but then I can just do the shape and get the data. All right. So it should have opened by now. Yeah. So if you look at here, you have this first row, which is the index of it, 0 from 0 to, you have the last one is 783. And then the last column is the label. So you have these labels, all 43 labels are converted into 0 to 42. So all 43 classes are already converted into numbers. But then you have to convert these numbers into one hot encoded values because these are categorical, not continuous. So there is no direct relation. Maybe it is not clear for you. Let me make it slightly bigger. Alright. So this is the top first row where all the indexes are there. And I'm just talking about in this indexes, if you notice, this is again column which is talking about how many rows are there. Totally 39,209 records, 39,209 objects are there. And you have 784 columns, which is 28 by 28. Yeah. 184 and 28 by 25, 28, and the target variable is labeled where there are 43 different classes. Alright, everything is number, and you will notice that the biggest value here is 255, and the lowest, smallest value will be 0 in this case. So this is the value you have to see, and 0 to, you have 0 to 255 is what you will notice. We will have to look at only input values. So that's this the data. You will not have more than 255 and less than 255. And let's say I think we have the data of 255 and so on. Now I'll close this data set which is input. Now let's go and run this here. Now here you have the Jupyter. I have first loaded the basic libraries to read the file. So pandas, I can read the CSV file or comma separated value or tab separated value I can read. And for computation purpose, I have imported NumPy. Only two libraries I began with. Then the second step, if you notice, I will also run this along with you. And second one step I have done is read data set, this available information on the traffic sign images. So all I'm doing is the alias of pandas dot read underscore CSV. There is this uh, I can read the file. Since I have it in the home directory itself, wherever this file is stored, I'm just calling that. If you have a problem here, you can just keep R before this quotes and it will run. So I will execute this. So it is a large file, so it took this much time. Now let us check what is there in it. So I am doing df.head. Head will provide the top 5 values for me. Now what I want to make sure is I want to separate this input values and output values. So I will drop the last column and push all the remaining columns in X and keep only the last column in Y. So therefore X becomes all my input variables, Y becomes my output variables. So let me run this. So the way we can drop them is I can do the axis is equal to 1, which means drop a column. This is axis 1 for column, 0 for row. Yeah, should be 0 for row and 1 for column. Labels column I have to drop. So I'll execute this. Now you have two different files. One file has X only input variables, another file is Y only the output variable. So let's check what input variable has. So you realize that there is only one column is where is this? One column is short. Only 785 columns are there. You can ignore the first one. That is unnamed. We will remove the unnamed also. Alright, now the next one that we have data pre-processing we will do. So as I said earlier case also, in the pre-processing we should bring down, scale down the value so that computationally it is not very high, and at the same time your distribution remains unchanged. So x is nothing but x is equal to x by 255. In this now you are dropping this line. I was wondering, if you have not dropped this unnamed, then it would have taken this and still wouldn't have learned anything from it. So yeah, I'm glad we have this drop the unnamed first column. So that's why axis is equal to 1. So you will not fill anything here. Now we also want to convert the so the data type is array. X is nothing but it has to be kept in the form of an array. So you are defining the data frame which was in a tabular format, converting that into an array format, and again assigning that into X. Now you will shape this array into the shape that we want. It is 28 by 28 by 1, and X dot shape index is 0. So reshape is the function available or the method available in NumPy. Alright, now you have the data ready. X is now in a matrix form of 28 by 28, and it is a grayscale version. So now let us split this into some portion of it for training purpose, some portion of it for testing purpose. So for that, we will, in the sklearn.model selection, you have train test split. So a train test split has that the train test split is a method in this model underscore selection where you can split the data using some sort of a percentage. So 15% I'm using. Yeah, it gets over, just 5 minutes. Have a seat. One moment, there is some announcement. You give me, let me complete this.
Yeah, yeah, yeah. No, I'm not interrupting anything. Because there are two videos we have to play.
You have to wait.
I already added. You just click on the.
No, you please tell her to wait. Just 2 minutes. It will be done.
2 minutes.
Yeah. All right. So let's do this train test split. You have an announcement, so we will also pay attention to that. Uh, in the in the split, we are using this sklearn.model selection. You are importing this. Using that, you are keeping test size. I'm hoping this is clear. Test size is 15%, 0.15, which means 85% will be there in the X train, and X test will have remaining 15%. Since we also said the train test place allows the Y train Y test, it is the output variable Y train and Y test, and you will have it. And now you are also saying it is random state and you are leaving one seed 101. It is only to make sure any number of times you run, still you have that split remains intact, and randomly it is doing. So I will execute this too. And now, before I go to the model, we will just see what is there. So for that purpose, I have imported library, and with this we will close the library here, and let us see briefly how the images are appearing. Sorry. So this is how the image is looking. This is a 30 kilometer per hour speed limit is mentioned. This is another 50 kilometer per hour, and keras.utilities I have kept .utils where I can convert my y values from a one-dimensional class to 43-dimensional class. So I'm mentioning it as 43, so it will convert this into ones and zeros. So this is also done. Now, before we build the model, given the time, we will take a break for 5 minutes. But before the break, I want, or maybe after the break, Vishnu and Anuradha ma'am will give you a brief intro to certain views. So it is 11 now. 11:16, we will have an announcement followed by I will review all the question and answers and then complete the remaining part of this model.
Hello. Yeah, hi everyone, welcome back. This is Vishnu from Blsckbuck. I'm the director of product innovation here. We have a couple of videos that we'd like to share from Anurag University. So have a look at it, and as soon as we resume that, Mauli sir will get back to the class session. All right.
Hello dear participants, warm wishes from Anurag University. I am Dr. M. Santosh, co-convener of this event. I would like to thank the management of Anurag University, Director Dr. K.S. Rao and Head of the Department of... Hello dear participants, warm wishes from Anurag University. I am Dr. M. Santosh, co-convener of this event. Hello dear participants, Hello dear participants, warm wishes from Anurag University. I am Dr. M. Santosh, co-convener of this event. I would like to thank the management of Anurag University, Director Dr. K.S. Rao and Head of the Department Dr. S. Satish Kumaran, and also the co-conveners Mr. P. Ramakrishna and M. Kiran Kumar. I would like to thank
Anurag Group of Institutions was established in 2002. We believed in three factors for any education institutions to grow. The first thing, having best infrastructure, faculty, and creating an academic environment. Coming to infrastructure, we have taken care in providing best classrooms, laboratories, library, equipment, everything. So we should have the state-of-the-art facilities. We have taken care, we have provided.
Anurag Group of Institutions, in its 17th years of journey, has received many awards and recognitions from national bodies. We were accredited by National Accreditation and Assessment Council of India with A grade, and all the UG programs in engineering and pharmacy were accredited by National Board of Accreditation. In the recent NIRF rankings, we were ranked at 169 across India. Our students not only got excelled in academics, but were also placed in reputed MNCs across India.
For any education institution, the teaching and non-teaching faculty is the backbone of that institution. So we have attracted best faculty, we have retained them, we trained them. Now the Anurag faculty is best. Anurag Group of Institutions was established in 2002. We believed in three factors for any education institutions to grow. The first thing, having best infrastructure, faculty, and creating an academic environment. Coming to infrastructure, we have taken care in providing best classrooms, laboratories, library, equipment, everything. So we should have the state-of-the-art facilities. We have taken care, we have provided.
Institutions, in its 17 years of journey, has received many awards and recognitions from national bodies. We were accredited by National Accreditation and Assessment Council of India with A grade, and all the UG programs in engineering and pharmacy were accredited by National Board of Accreditation. In the recent NIRF rankings, we were ranked at 169 across India. Our students not only got excelled in academics, but were also placed in reputed MNCs across India.
For any education institution, the teaching and non-teaching faculty is the backbone of that institution. So we have attracted best faculty, we have retained them, we trained them. Now the Anurag faculty is best at OBE methods, teaching learning methods, and they have been publishing their publications in peer journals. We have come from 190 students in 2002 to right now there are 6,500 students, 700 plus teaching and non-teaching faculty, and best academic environment. We are heading towards Anurag University in the coming academic year. We welcome you all to this small but vibrant and dynamic institute.
Q&A పెట్టుకొని మీ ఫేస్ పెట్టుకొని
Sure. Good. All right. Welcome everyone, and hope the message was powerful. I'm not able to see the questions today. I'm not sure if you have asked any question or they are lost here. I'm not able to see any question. Maybe. Thank you very much for bringing us into 3-day session. Thank you. Is it further down? So, yeah, Miss Anjali. Okay. My voice was breaking. Probably in between when you have the processing done, voice was not clear. Probably when the model is running, probably I'll not speak. Please solve a problem. Which problem? Yeah, there's one question. We can initialize the weights by either randomly or we can use Xavier Glorot initialize. Which one is preferable, sir? I think if you have the preset initializers, you go ahead and use. In most cases, I've been randomly generating initializing weights. I don't have a problem. It is working well. I can't since I've not tried with this Xavier Glorot, I can't comment, please. how to decide the number of filters while building the model? Yeah, good question. So there are some studies that says depending on what you want to do, you can even preset something like Xavier Glorot. You can do for blurring, for brightness, you have certain predefined filter weights that are available. Typically, if you need more accuracy, you can increase these filters to up to 30, 32. I'm noticing. If you already have a good depth and the classification is just a binomial classification, is adequate data, then you could use 10 filters. So these are the two common numbers I see, 10 and 32 depending on it. However, there are some heavy models where more than 32 filters used. Screen is blurred, yeah, internet can be at the time of execution. Where the optimizers like AdaGrad, yeah, AdaGrad also works well. Ada Delta and Adam are useful. They used to update the weights, that's right. Adam is found to be super fast in reaching the when you have let's say, yeah, so when you have the local minima and global minima. So if you have small hills like in Himalayas and there is one big valley, that is what will bring you down to the sea level that we talk about. So identifying which is that big valley down or big mountain range down that you have to come to reach the sea level. So for that Adam is good. There are some studies where Ada Delta and Ada Grad, those also were helpful, but more studies subsequently proved that Adam is better. Then next question is how to decide the first parameter value in dense. Yeah, if it is the input has to be given as is. So you say you input size is so and so and this is the input. You will read the input in the dense. So you will say input size is 28 by 28 or whatever is the input size. If it is convolution, a two-dimensional, otherwise if it is data is coming from convolution to neural network, the ANN simple networks, you don't have to do anything. If it is simple networks, you are starting the input size you mentioned and input has to be called. The parameters are if they are randomly generated uniform values. If you want to define those parameters, yes, you can only say whether it is random or uniform. We can't go ahead and create for every one. So we can check in the dense function. We can go and see, for example, I will show that on the screen how to go and see different parameters and arguments that we can pass. Next one that we have, thank you, there somebody said easy to understand. Next question is weight matrix should be created by us or it generates automatically. Yeah, I think I'm glad all the many questions are around that weight matrix or the parameters. So initially you can have a uniform one, it automatically takes uniform random numbers in the weight matrix, and in your iterations it will improve and come up with the right weight matrix. So in the image recognition, that weight matrix is nothing but a feature. So it is like a feature edges, you will get the data in them. So response to this is system generates automatically. How to convert or store image data into a CSV file. You have the way we have read, you have write available in PD. You can write it into the CSV file. So you can check the function to write the CSV file and you can do it. That is there in pandas. Next is if the batch size is 10, then for each image we have the loss. Now we calculate the gradients. Similarly for second image also we have the loss and the gradients are calculated. Where the first gradient, where are the first image gradients are stored. Yeah, excellent. So it is like virtual. So after the one image, let's say the batch size of 32, right? 32 as one block will go and a new set of weights get generated across your model. So the model that we created had multiple layers. You had convolution layers and then you had flattened layers with some hidden layers available. Now so the weights are temporarily stored, you can always write those weights to see what is it. So you can call them in some sort of a CSV file. So you can have a JSON as an output, JSON as an output you can get and see. So virtually it is captured, and the same thing is presented for the second batch and it gets refined. Next one, after completion of 10th image, all the weights are updated by using gradient descent also. Since we are using Adam as a error rectification method, so it's a sort of so it will go and modify all the weights using, say, a concept is similar to gradient descent. It will go and make changes. How weights are calculated? Is there any approach available? Initially weights are uniform, later the error determination, the cross entropy will say how much is the error. To rectify that error, we use yesterday we spoke about lambda function, learning rate, and then we spoke about derivative. I said in the curve you can use this tangential one, a small change, theta change, so you can do a derivative, derivative of error given the derivative d of weight. So through that you can compute, you can reduce that small value from the initialized weight and to get a new weight. Next one, okay, what are different types of loss functions used and what is the default loss function in TensorFlow? So loss functions always have to be explicitly mentioned. I will show you where we have when I go to the regular main mode. So there is no default loss function. You have to always it is a necessary argument that you have to pass. So in the compilation you have to pass which loss function, which error rectification that you want to use. The next question, state the difference between sigmoid function and a Gaussian function. When we use sigmoid and when we use Gaussian. Let me see if I can get the time to provide this response. How to prepare new image data set means for an entirely new scenario, how CSV files for images are prepared. See, you have these images, you have to convert them into pixel values. So I said there are two methods. One, you can use a computer vision tool, CV2, which is there in OpenCV. OpenCV is a library. You do a pip install OpenCV and then you can use that library to read the images and then convert that into a direct pixel values. Another is SciPy, SCIPY, that is another library where you can read the images and convert. So you can check it online, you will find it. If I have it readily, probably today itself I will share. I want to identify, next question is, I want to identify n number of objects with real-time video. So I am reading these questions from your script chat. I want to identify n number of objects with real-time video. What are the restrictions and issues involved? What are the processes and algorithms supporting for this work? See, you will convert the video into frames. So maybe how many frames you want to take per second, and that becomes one input. So you will have then multiple inputs depending on those frames, and after that the frame is nothing but an image. Let's say 10 frames per second you are capturing, a video is captured and it breaks the video into 10 frames per second. In a second you will have 10 different images. All these 10 images are presented as an input and rest of it is same, convolution and flatten. Next question, what happens if our model is overfitted? High variance is the problem we will get, but please explain in detail. I will take this question and I will go and probably, this is a very important and useful question. The person asks what happens when there is a overfit. You don't see the screen right now, but for my reference I am writing overfitting. I will answer thoroughly. It is a very useful thing. What happens if our model is overfitted? We'll see. Next one is, when is it suggested to use TPU and GPU in image processing? So there are some hardware that we can use. If our central processing unit, the processor of the computer, which is you have this i5, i7 processors, typically we use of Intel. Now if this is not working, then you can have a dedicated processing unit, which is graphical processing unit, GPU. Now all our machines will have a very thin graphics, that's how we are able to see on our screen graphics, but then there are some dedicated graphic cards. Nowadays some computers, they are providing the GPU. So this was used for video games extensively. People who play video games, they get a GPU based model. graphical processing unit. So when for any network models, recommended is you go for a GPU where it can have multiple epochs. If you see, I am running a very high powered operating system, but even here I am using one epoch or two epochs, or sometimes I keep some layers hidden. So if you have to run it on Colab, that is better. Colab is freely available on Google. We will give you some documentation on how to go there. TPU is a tensor processing unit. It is a variant of GPU, I would say, and it is promoted by Google. So they say that this is computationally much faster. So they work on many different models, and I think particularly this BERT, bidirectional embedded representation transformer, or recently they come up with this MENA, the text model. So it's on some 1000 TPUs. It ran on for over 30 days for the model to be completed, something like that. So tensor processing unit is more effective. So when is it suggested? So whenever you are working on network models, more epochs, more layers, go to GPU. TPU, I think it is when you have 50-60 layers, then you can think of TPU. Otherwise GPU is sufficient for majority of the research work. How to identify whether the model is overfit or not? Yeah, so you have during the compilation stage, post compilation stage, you will notice epoch accuracy. What is the accuracy? And if you have the training data set accuracy very high, but then in the evaluation if the score is low, then why not I move to the screen right away, because this is important for you to understand. Screen, yeah, you must be seeing the screen. So the question that I have now is, what happens, yeah, how to identify whether the model is overfit or not? So when you can see here, let us go to our problem that we first looked at, one simpler problem that we saw, which is yeah, here we were looking at the MNIST data set. Here you have two accuracy values I will show you. One accuracy is when we ran this model, I'm hoping you are able to see the screen. When you ran this model, this is all the model you have, then you compiled the model and you are fitting the model to generate the parameters. This is where you are generating parameters. Now here the accuracy that you are getting 67% and 83% is the accuracy on the training data set, and then this evaluation you are doing on the test data set. See here X test and Y test, while on the training X train and Y train. And the accuracy here you get from this evaluate function method is on the test data set. 97% it is showing because I think I ran this multiple times in the morning to make sure it works well. 2-3 times I ran. So that's why number of epochs were more. But if you have the training accuracy at 90-95%, but test accuracy is at 80-75%, then you say it is overfitted. It overfitted to the training data set, which means it understood the training data set so well that it cannot be generalized. That's why you say overfitted models have very high variance. Something like a simple example for this is, let's say you are doing a classification as an example, and you have the data like this and you draw the line. So these are all different points. Now in this case you can have some dots here, and then you have all other multiplications, let's say like this, or the other no, and this is yes kind of thing, and some no's here, and this is all yes. Yes and no is what we are trying to do. So if your model, instead of generalizing a line like this, if it ends up drawing in this manner, let's say the classification it shows is something like this. You have this kind of curve, and then you have this, and let's say if it is so it can be, there can be some madness where you have a line like this. Now this is perfectly segregating. This is all yeses are here, all no's are here. You know, straight line really gives you, if I say other models, generalization models will have some errors. This one, these all have errors. So this red colored one, now you see here, the red colored one is overfit. It overfits so much, now you can't generalize. You end up getting in the test data set, and in the real world testing, you will have lot of errors, though your accuracy here is 99% or 100% here. or let's say we can't keep 100%, say 99. In fact, in the training data set you can even get 100% accuracy, that is possible, but in the test data set is where the actual testing happens. This is called overfit, and in this the variance that it is accommodating is so high. There was another question that has come on the overfit. Here the variance is so high, the bias is very low for the generalized data set. So high variance and low bias to accommodate new types. This is all part of overfitting things. Now, assuming it brought some clarity to us on this. Next question that I have is how to if the image resolution is high, then which one is preferred, GPU or CPU? Image resolution means number of pixels higher. So I would recommend anything you have to scale them down. So let's say you have scaled down to 30, 28 or any number like that, 64, you scaled down, it's fine. But more than this resolution you are working with 300 by 300, you are retaining, then I would suggest you should go. You are correct. I think higher resolution, you need higher processing, therefore go with it. My recommendation is in CNN, you always scale down the numbers by doing divided by 255, so that computationally at least it is some bit of relief over there. So I'm glad hopefully we have some majority of the questions have been looked at. If there is anything more, you can always post to extract. There are some more questions. I think just give me a minute more, I will go through this as well. It says, is it a correct way to extract features from images using AlexNet in MATLAB, store as CSV and classify them with the external software like Weka? You can extract those features. In fact, I was attempting to show you all a default dog and cat classification using a VGG16 model. So I realized that the time may not be adequate, so I parked it aside. I have not used MATLAB before, so I can't fully answer, but in general, yes, you can use AlexNet or any other pre-trained model to extract features, and then the terminal one you use your own model so that it happens faster, the computation happens faster. How is CNN different from reinforcement learning and recurrent learning? It's a very, very loaded big question, how CNN is different from reinforcement. I will probably answer at a peripheral level what it is, just to get some grip. CNN used convolution, where it has convolved the data, a large data into it has using some sort of feature filters, it convolved and generated maps. So this process of rolling it down and aggregating the data is called convolution. This model used. Now you have a recurrent model in the recurrent networks. This is also called conv-net originally. Then in the recurrent nets you have the data which is managed in the time step format. So you have, this is one time step of the data, and this is another time step of the data, and so on. So this is, let's say, how are you. So then how is another one vector here. So how gets converted into some sort of a vector. Let's say this is how, and then R and U. So this time step is captured in the recurrent neural network. Within this vector will go through the same again whatever we discussed of the sigma and then the quashing, both of them it goes through within this network, each of these cells. These are the recurrent cells. So this is very useful in the time series problems, the recurrent one, because it maintains the time step. It is also extremely useful in the text data set. In the text we have natural language processing, we have words where the sequence of the words can be tracked in this. CNN cannot track the sequence of the words in this format. Now there's also this question, what is reinforcement learning? So in the reinforcement learning, the model works in a slightly different way, where it is reward and penalty method. So reward and penalty method. So you will go ahead and make the adjustment, error rectification. Whenever there is a reward, you will do more of that. whenever there is a penalty, you will do less of that. So if it is a wrong thing, then there will be penalty associated, then you say okay, this is not the path to go, and whenever you are rewarded, then you say this is the path to go. Let's say you are playing some sort of a maze, and then in the maze, if you are going in the right path, you have in between some sort of let's say you are going in the right path, after every 2 kilometers you have a reward. So the reward here is let's say you will get water, banana, this season being mango, so you will get 2 mangoes, one of them is Himayat you will get, so and then 2 bananas and probably a juice you will get after every 2 kilometers. So you walk for 2 kilometers and you realize you don't have any reward, so you will say no, I will retract and go in another direction if you have 2 options here. So in the similar way, so reinforcement learning works. This is useful in video games, so it can play Atara games, it can play. It is also useful in the physical robots. So one of the things that we are attempting to research is make a humanoid where and of course we will have fewer degrees of freedom in this humanoid. If we can bring reinforcement learning here, so that those movements, the electrical movements through the signals can be passed for operating the legs as an example, but we are not working on the bottom part, only the hands and head. We are trying to do some experiment to see how it responds, a talking humanoid, let's say. Alright, these are the high level differences between a CNN model and RNN model. So all are you can say network models that we have. Next one that we question here is alright, so what is the difference between feature map and feature vector? So I'm not familiar with feature vector. Maybe if you give me more details, I understand. Maybe I'm guessing feature map is possibly with 2 dimensions, and here in this case we called it as feature map because we have 2 dimensions, and I'm assuming feature vector could be a single dimension output, and still it is a feature of your input data. It could be, so if it is a 1-dimensional flat one, that could be a feature vector. Maybe you may refer to alternate sources to know more about it. If the model is overfitted, then we have to add regularizer. Please explain, sir. Overfit, yeah, there are different ways to do the overfitting. Regularizer, how I can explain here is, yeah, first of all, what is regularizer in a weight reduction? So normally we say I want to change the error rectification. This comes under error rectification. Once you determined what is the error, the new weight is the, let's say, initialized weight minus the derivative of the small change in this weight, small change given the error that we have received. This would have been the formula. Now however, what happens is sometimes we will miss the minimal value, we might jump. So this rate should be further lesser. So we keep some sort of a regularizer so that the transition is not fast. It's very small, 0.05 or 0.005 also in some cases. I normally keep it as 0.5 of this derivative. I think 0.5 is sufficient for me. So we keep this as a regularizer so that the change, unit step down, change to the weight to form a new weight is very, very small, so that I will get the bottom values. There are other regularizers for overfitting probably that requires more time to go into the details. Can we get your email ID for posting some queries in case? Yeah, while the best one is you can get the details through Blsckbuck Engineers and Anurag University. They have requested me to provide the support. I'm also giving, I'm writing here the email ID you can look at, or I will tell the Blsckbuck team maybe to post my email ID here to the chat so that you can write to me. So it is at the gmail.com. You can use @gmail.com. My name is Mouli, M-O-U-L-I. So mouli9@gmail.com. Pardon because I am using this particular thing. I could have probably used a slightly different one. So let me keep it here once again for people to look at in case you want to write. The best way is the Blsckbuck team, because there are many of us who are helping them or who are supporting this faculty development program. So any of us could help you. This is my email ID. Alright, next one I'll see. I think we are good with the, thanks for answering. Yeah, I think I tried to do my best. Feedback link, you will get feedback link. Alright, so the last, I will have to necessarily complete our algorithm. We will go there and let's see. So we have completed till this is the model we were going through, German traffic signal. We went through. Let us quickly run. Initially we have got the NumPy and Pandas libraries for linear algebra and to read the files. Then we have this German traffic signal. It is supposed to be GTSRB. Okay, GSTRB. Okay, this is stored as GSTRB. I will change the name here. It is German traffic signals value. So I will now call simply read underscore CSV in Pandas. I can call GTSRB. So I changed. It is now reading. That's how the processing is taking time. Whenever it is processing, I better not speak, otherwise voice may not be clear. Now I will check this first 5 values we can check. This is not compulsory, but then once we see this, any other information you can do .info, .describe, but important is you have to now create an input variables file and output variable file. So x is equal to, we will drop other things we've created. We can check at a high level what it has. Now next step is pre-processing. Pre-processing, we are using 3 steps. First step, you are normalizing the values to 0 and 1. Second step is you are dropping, the first column is just an index column for every object we are dropping, but it has no details. Then third step is you are creating the shape from a table to an array of 28 by 28. So 2-dimensional array you have created. Next, you are creating train test split with 85-15%. Somebody asked what is the PIL? It is a library which is there. So in this library I have image, so I can read the images which here. Otherwise you can just skip matplot library completely and still it will run. So we have no dependency. Let's say we will remove this part and we don't want to see what is there, and straight from the train test split we will go ahead and run our model. So to run our model, it is important to further pre-process the y value. We could have done the pre-processing even before this also. Y we have to convert into a matrix of 43 dimensions. So y, both train and test is converted. We have done till here, and now to build the CNN model, first step is we have to read the input. This is the first step. So to input is there under the models function in Keras. So with Keras, since we already ran, so there is backend TensorFlow is running. So I will import this method input so that I can input has certain parameters. You have to press shift tab to see what are the arguments, what are the parameters you can pass. So I have clicked the shift tab to see input. I can take shape. So shape none, so it can take default, batch, name, data type, sparse, etc. Shape is equal to, I am giving the input here. I can have more details of what is shape. One moment, yeah, here you can see. So shape, I hope you are able to see. I'll increase the size of it further. Now here you see a shape tuple integer not including the batch size. So shape is equal to 32, which means it is a single 32 dimensional vector. It's a vector. So you can have batch size defined, you can have 32 dimensions with batch size and so on. So all these options are there. You can go in, look at each of these methods and functions what they have. Now I have read my image as 28 by 28 by 1 because I am also giving image size beforehand. So once I run this, next thing is I have to create a model. In my model that I am trying to do, so probably I will create the structure of the model beforehand and then I will come here. So let me say, so in the model that we are trying to do, in our model, we are first going to use convolution. We will use convolution with, so one block is here, I don't recall. This is definitely 28 by 28 and it's only grayscaled one, and I think we are using 32 filters. Yeah. So we'll use I'm using the 32 filters of 3 by 3 we are using. These are filters are 32 and the size is 3 by 3 we are using. So and then I'm using ReLU, and I'm using after this the max pool model, and with the 2 by 2 filter, and stride is equal to 1 in both cases. Here also stride is 1, which means it transitions step by step. Here is a stride is equal to 1. Padding I am keeping same, which means no padding here. So this model runs. After that I am flattening everything, and at the time of flattened I am saying that all this data from here this should not so this becomes input value. It will directly when it is connected, I am dropping 50% of these connections, and then I'm suddenly reducing it to some 784. So you will see all of these details as I take you through. Let's see in the code wise. Now from the input, next to build the model I need to create the layers in convolution. To create the layers, conv2D is a function available. 2-dimensional data it takes. There is also conv1D and conv3D. 1D is typically for time series problems, or everything you convert into vector and run. Second is activation. Activation functions we looked at sigmoid, softmax, ReLU, leaky ReLU, linear unit, directly linear unit is also there. Activation. Max pool 2D is for pooling purpose, for max pool, which is you take 2 by 2 or 3 by 3, whichever is the maximum value, that becomes the output. Dropout we did discuss to avoid overfitting. This is the way you could regularize. This is one method of regularizing, by dropping out some of the connections. Now I will run this, and then I am creating my first input layer. When I am creating my input layers, I must refer to the input size. This data has to come, and in the input layer number of filters are 32, filter size is 3 by 3. So these are so again you can check here, do a shift tab, then at the value you will get what is there in conv2D, or normally people I think they highlight this particular function and then they do a shift tab, and you get this input signature. You can see the complete data of what are different parameters it takes and what kind of arguments you can pass. These are all default values. You have to necessarily, if you don't have any default value, then you have to necessarily give the value. Without filters it will not give you any result. So it will throw an error saying that you have not defined filters. So it doesn't take any default filter number, it doesn't take any default kernel size. But then strides, even if you don't give any stride, it says 1 by 1, which is 1 horizontal movement, 1 vertical movement. So stride is equal to 1. I said padding is valid. Without any padding also it will take. Data format it can take. Dilution. Activation is none. If you don't give anything, then the sigma value, the added values just go ahead. If you, it is as good as a linear, it's a linear unit. So if you want to give any other activation like ReLU, my recommendation for all the hidden layers, so then activation is equal to ReLU, ReLU you can write. Use bias, kernel initializer. Yeah, so the default one is Glorat. I think one of the professors was referring to it. Thank you. I will do more reading about Glorat. So this is a default and it is uniform data. So probably I was not aware that this is a default one. That's good. Kernel initializer is this. You have more options. You can go down and see further. Of course, there are also other places in Keras notes. You can go and check what are different arguments that you can pass other than this uniform Glorat values. Bias initializer, bias B we say this is kernel initializers are all W's and bias initializers are B, and then the values keep adding, and so on so forth I would say. So let us look at the values that we have given. After activation, I said since it is the first layer, you got to provide the input shape. Input shape is image size 1. Sorry, it is jumping. And then at the end of it, instead of me adding the layer here, model is called model.add. I could use the other one. Instead I am using this braces inputs, which means take the inputs as a starting point and add this layer to it. So convolve the data. Now, so once I do this, I am using second convolution layer. Yeah, so this is convolution layer 2, I would say, input layer convolution is the first one that we have done. Now, so we will execute this as a model. Model, it is not running anything computationally. We are just preparing the model. Since yesterday somebody asked, can you give line wise? I have converted everything into line. So I have created second convolution. Now, again, in both the cases, activation is relu, but in the second one, you will notice I am not giving input shape here. It's not required. I am referencing the model here is the first model, in the second one as well at the end. So here the same model. However, for convenience purpose, I am using model again and again. If it is confusing, I can change this to, this is model 1, I can change, and then I will say this is model 2. It is just for convenience, and then here I will make a reference of model 1. So then, since next step is max, after 2 convolutions I am using the max pool. In the max pool I am saying it is, again you can check what are the different functions. You can have shift tab and you will notice that what are all are the default values. Pool sizes, you don't need to give pool size, it is 2 by 2. If you want to make any other change, you can change. So those default values are also here. Now I will run this pool size. Stride is also 1 by 1 is the default. After this, I am dropping out some of the 30% of the connections I want to drop out, so that it becomes faster for me. I dropped out. Now next step is I am moving to flattening this network model. In the flattening, I will use, there is a library, there is a function called flatten. So it is an empty one, then it will convert the 2-dimensional into a flat layer. So I will run it. Now the flattened layer, I will call it as model 4. It's just for convenience purpose, I am changing the names, and model 4 is this. So once I flatten, I have to create a neural network, a typical network. So there is this function called dense, wherein I can add and again create activation, like the way convolution 2D, conv 2D we have done there. So I will import this library too, and now I will create the dense is equal to, maybe a dense I will call here, or maybe dense 1 is equal to, dense is the function, and 2048 is the number of values I want to take, and model, let's say the 4 is running there. And now this is model 5. And then I will go with the dense 1. Here again I am further reducing 50% of the connections. So this is now done, and this is hidden layer 1 of ANN. I am creating 2 more hidden layers for convenience. So let me quickly make these changes so that it will accurately run. So let's say this is dense 2 and the model 6. So I will, then I have the third hidden layer. It is, if you notice, I am reducing the size of the hidden layer. So number of neurons that are coming, I am bringing it down. Finally, I know my output is 43 different images. So the final one I will share. Dense 3 is taking model 6, and the final model 7 I will keep here, and this will run. So I have name model 6 is not defined, so which means this did not run. Yeah, now it will run, because probably this one did not was not executed earlier. And then now this is done. Has this been done? Yeah. Now finally I have to import the model. This is where I can run my model. Everything has to be pulled together. So again, this is there under keras.models. So I'll import this, and my final dense, or the output layer, is this output layer. More than final density is, I will call it as output layer it is. So this is what we are assigning, and that is nothing but dense, and my total number of outputs are 43 classes. Activation is softmax. You will notice this is a multinomial classification, and the model that I should take is an output of model 7, which is what in the hidden layer 3. So my final model is this output layer. The outputs is output layer. Inputs, again here you are saying inputs is inputs where we have assigned the actual input there. Now I will change this and run, and everything, my model, if I write model or final model, let's say for clarity, I will share the same code with you all, and if I run this, I prepared the model. Once we prepare the model, then you compile the model using which loss function and which optimizer. I am also trying to get, there are some metrics that Keras allows, accuracy is one of them, so we will just get accuracy along with the other data. So without this also, the model, basically in the compilation you have to use which error you want to determine and which method you want to use for rectifying the error. So it's called optimization technique. These are called optimization techniques. So optimizer is equal to Adam. So you can see the other values by shift tab. So this did not work for me earlier also. Yeah, now it worked. So this is the compile has source, file name, mode, flags, etc. don't inherit. So optimize is one. So you have these details available for reference. Now let us run this. Let us compile our model. Where when we compile model, tensor has no attribute compile. Okay, because our tensor is kept as final underscore model, so this will run now because this is where our this model is. So we have the compile as an in the model class, you have the compile as a object, let's say, and then you have these two parameters that you passed. Arguments are categorical and Adam. Now model is compiled and ready. You have to run this model to generate those parameters. So I am creating only one epoch for speed. So fitting the model where you are taking the input training data set X train and Y train. So where X train has 85% of our images, and those images classification is here. Again batch size is 32. You can choose, I can say batch size is, let's say, 50 and epoch is 1. Verbose is 1 or 1 and 0 are options. If you give verbose 1, it will tell you this bar, the progress bar it will provide. So that's how I provide this. Let's run this and see model.fit. So this is the final model. So yeah, now it is running. So it will take some time and my voice also will not be clear. It is taking 13, yeah, or 9 seconds, very very fast. Oh, I thought it was seconds, but I realized it is minutes. It is taking 8 more minutes. Let me engage you with something else, but it is good if we can see the results. Let me see if you have any questions. You will also notice, because it is processing at that high speed, my voice may not be that clear now. Yeah, you will have audio disturbance in between also, is it? Let me... Thank you, Usha ma'am. I think I subsequently addressed that change. Okay, I have to further change. I thought I changed it. Oh, okay. Yeah, I have not made this change. Thank you, Usha ma'am. I think still, if I have not changed, then the dropout didn't happen. So this one is not really impacted at all. Without dropout, the data from max pool layer directly went and got flattened. Okay, maybe next one you can reduce this. But which is the reason why possibly the total time also is taking much longer, because I didn't drop. That was extremely critical when I am transferring from convolution to flattening. I must change it. So since this is taking time, what I will do is I will stop this method, and probably like the other you have identified error, I will go and run again and hope that this will become faster. From here I am running the files. I'll have to compile everything again. Oh, it is taking again more time. Now I will reduce this to my computer, I think because there are many other things running, it is showing me 18 minutes time, but you can be assured that this model is running. So I also, what I tried to do here was I'm stopping this model, otherwise we will lose lot of our time. But the moment it is running this, you can be assured it is working well. I will stop this kernel, so you will have this error. However, in reality, post this session I will execute this and send you this model. So how can I reduce, how can I make it faster so that the number of, so I'm going to make this faster by reducing the probably the drop rate will increase further. The drop rate is good enough. I will say from here I will only keep 500. Here I will keep 200. So a big change. Let's say this is 13 and okay. Alright, so probably it is also taking efforts. Just give me a minute, I will run from the beginning again everything, so that it should be faster now for me, because I'm reducing the number of neurons, so weights will come down now. Yeah, you will notice that 18 minutes became now suddenly 4 minutes. It will run now. I will take, by the time it completes, accuracy may get affected, but at least we will know that the model worked. You should have 10 epochs at least to get something accurate. Let me take all these questions together so that I can answer. Yeah, thank you. How to, yeah, there are a couple of questions. Please share code. Definitely, ma'am, I think will share this code here itself with the Blsckbuck team. I will share. Just how to reproduce accuracy of models in TensorFlow. Reproduce accuracy, which means if you want to show what is the accuracy, then you can just say verbose there and it will provide you. Default it will give you loss in accuracy. But if you want to take a print of accuracy, you have to write a print function. How much of mathematics, there is a question, how much of mathematics and statistics are needed for CNN? I would say algebra and calculus you require. I have one, there is one university in US, they have a wonderful document on the math required for deep learning. So there are roughly 10-12 pages. I will share that with you. My voice may break now, you have to please allow it. Yeah, someone said you will get to know. Yeah, so this is how you can reduce cycle time, especially if you are showing it to students and you have to demonstrate. You have a low power machine, or you want to quickly do even on a collab or a GPU. This is better. How to evaluate the output, we will come there. I have this model running. 2 minutes more it is taking. But you see here the accuracy is slowly now improving from 5% to 2, it has come to 30% accuracy. So which is good. And the number of data set that out of 33,000 objects that it had, 33,000 images, it has processed 20,000 images. Let me pick up one document in the meantime for you all. So we have have one document that's so wonderful. So if you have understanding of it, that is sufficient. So maybe what I will do is I will do some bit of search. So I will I'll keep this like this break. However, I'm still running the model, and I want to check math for ML. Yeah, I think this is the file. I think I found the mathematics for machine learning I have, and I will share this document now. However, I will talk about it right away until the model runs. Let's see till where is the model run. So are we on the mode of main live? Yes. It is taking 24 more seconds. I think we can just wait and see how the loss is still there. 1.8 is a high loss. I think you have to further reduce this loss. Obviously you should run more epochs. Accuracy has from 5%, it has moved to 47% now. 47, 48 it might close at. Perfect. I think it closed at 48% accuracy. With this accuracy on the training data set, let us evaluate. There was a question from another faculty, how do you evaluate this output? Now I will test the same. I have this evaluate as a method in the model. Model is we are using it as final model. Yeah, otherwise it will again run, because this is where the model of Keras we have stored. We have assigned it to this. Now here X test and Y test are that 15% data I am using, and see what will happen, what is the accuracy that we will get. So not bad, we got 88% accuracy here on the test data set. So what I have done, because this German traffic data set is all together, and I pulled all the y value, all the y variables as output here. One of our colleagues, Vamshi, he has put together all these output variables so that we can check just online how it works. So we can take an image from online. Right away I will take an image of one traffic signal. Let's say traffic signal, or we will take some 20 kilometers per hour signal we will take. So I will take this and store this in my system. Save image as probably I'll store this, and what we will do is we will run how accurately the machine will be able to predict what this is. Let us test that part, and I will store this as image 2, because I think there image 2 is there. I'll store this as image 2. Now let's go to our model. Where is the model we have? And so this is not the model. Yeah, so I have now stored it as image 2. I don't know whether it is PNG or JPG, but let's run this and see. 50 kilometers, so it is a different one. So I'm checking whatever we copied now, that 20 kilometers or so, what happened to that file. That is image 2, and it is yeah, it is JPEG, I think. It is JPEG and 20. So I'll have to convert that JPEG into PNG. Okay, nevertheless, to avoid further time consumption, because I have to first convert this JPG into PNG, and then I can run. Okay, we will go ahead with image2.jpeg. I'll see if image has ability to read JPEG directly or not. If it has, then we can test this itself and plot show. Yeah, it is not able to read JPEG. Image2. Yeah, this is a PNG file that it showed earlier to us. Alright, now I'll go with the PNG file. So in this we have the 50 kilometers per hour. This is taken from outside. It is not from the pictures they have. This is the real world data. Though the accuracy over there was 88%, you will realize that I am transforming this image into resizing here. Somebody asked, how do I take the data and resize? So here I am using image which is there which is available here, but you can use SciPy, that is a better one. So I am running it and I am using a CV2 from OpenCV to read that image and say what the image is. This is okay, I have to run this. There is an error that I am getting. Tensor object has no attribute predict. Yeah, this is a final model thing. We call it as final model. So now this is showing as 30 kilometers per hour. So assuming that we have input this data accurately, because I think 4 or 5 times I found this as wrong ones, or I could check at least if this is correctly added one after the other, then it is wrongly predicting this output as 30 kilometers per hour. So there is still a lot of improvement that we can see. What is the shape of the image, you can see. I'm hoping this has brought some clarity. A quick recap of just algorithm I will do. We have downloaded libraries initially for computation and read the file. Then we read the file. We checked what is there in the file, but once you read the file, you are segregating input variables and output variables. After you segregated, you have to process both input variables and output variables. You processed input variables and converted a vector format data into a image form. Objects you have converted. Then the data table became images here. Then you have split the data. Here you have converted the y value also, split the data, and you used utilities of course for this purpose. After this you built a model. We built model using 2 convolution layers here, and then one max pool. Then we have flattened it and created neural network. In the neural network we created 3 hidden layers and in the dense with significant dropouts for speed, and finally we have tried with the final output layer. So once we created the model till here, we have then compiled using what error determination method and which error rectification method we have to use. So the loss or cost functions and the optimization we used. Then we fit the model. This is where the learning is happening. This is what takes maximum time. Your computationally, this after loading the dataset, this is the highest computing time. Whenever you are using pre-trained model, that's why we always say the last piece from a pre-trained model you should remove and use your own, so that the speed can be improved. So once this is done, it will give you training data set accuracy, and then you can test the model on the test data set and see what accuracy it is. Rest all is only for live testing, for image reading, etc. We'll share with you these two algorithms, these 2 programs to you for reference. I have somebody asked what maths that we should know. I think I would recommend this particular piece. This is one of the universities in US. They have compiled. It is a work in progress, but most of it is already filled. So we'll share with you this. Let me also increase the size of it so that I can talk about some lines of what you should know. Important calculus you should be familiar with. The derivatives, partial derivatives, chain rule is coming from here only. Now I will just show you everything. Yeah. Now differential calculus here, how you will compute the error y minus y hat. So y is, or y hat minus y. So whichever you can say, this is the ground truth and this is the predicted value. Y minus y hat or y hat minus y both yields same thing. So because you are squaring the data, so the negative values will go away. So once you have this error, we spoke about limit functions. The small change that you have this, so how it will have an impact. So on and so forth. You have polynomials. This is important if you can do these equations. All the exercises are here, and I'm not sure if answers are there. You can always try them, so that gives you greater comfort. Then integral calculus, we spoke about convexity. Little bit of understanding is useful in convexity. Now then linear algebra. So these 2 are critical, calculus and linear algebra. In this you need matrix multiplication, vector spaces, dot products. See the entire Euclidean, so it's called Euclid. How do you compute the distance, Euclidean distance? That is important. So vector norms I'm assuming, yeah, how much ever we read, I think still refreshing is better. Euclidean norm and Manhattan norm. I think Euclidean is what we use commonly. Then you also have more details about the matrix multiplications in this. These are all exercises, examples. I will share this document, you please try. Projections, of course, is good to know. Important matrices. So whenever you see the W values is transposed because you are doing that matrix multiplication, so it's a transposed value, row by column you will be doing. So I think some details are also available, determinants and ranks here. Let me quickly see any other topic here which is multidimensional. Yeah, eigenvectors. So eigenvectors and eigenvalues is not available in this, but eigenvectors is where you will add the distances using cos theta, I would say. Multidimensional calculus. This is adequate for you to really get on to what are different. If you can then get into the linear regression and that becomes key, linear and logistic and softmax. So those equations automatically you will get. Support vector machines, you have the kernel sizes, max margin, and decision trees you will use cross entropy only. We will use for decision trees because the heterogeneity we can capture. Otherwise you can use Gini index. So and then you can do sampling, different methods where random forests and ADA bootstrapping and sampling can be, you can play around so that you will have greater understanding. Then unsupervised learning, you have again few other equations that help recommendation systems, etc., but they are not that complex. Now when it comes to the neural networks, we've already discussed at length. So this should be good enough. Let me see any other questions that you have so that 12:30 we can wind up. Kindly share the materials, you will get it. In real time, self-driving cars may face many objectives. In real time, self-driving cars may face many obstacles like fog, rain, dirt, etc. that can affect the accuracy. How to handle such scenarios? How to visualize the CNN architecture we developed as an image. So I'll see if I can send Professor Rajalakshmi, if I can take that out right now. Transfer learning, I wish I had the time, but at least I will share, I'll share the document, this document also. I want to show you one example. Car has, for example, Tesla car captures a significant amount of data of 250 meters ahead of it. They have this radar technology that is available, and all of that data is processed. That there they are using object detection and multiple models are being used. Last one that I want to show you is the Codentious method, which I spoke about. Just give me a minute. Where is it stored? Yeah, face recognition. So probably I will also share with you different examples of what we can do. 3 different examples I will share. So face recognition, this particular model that I'm going to talk to you about, it captures 32 different points on the face. So what we are doing is a single model. Here it captures 32 key points and then again convolution runs in it and we get the output. So you have optical quality inspector, again minor cracks that we can't see using naked eye. We can use an IoT device and capture this data, compare with the trained model parameters to see if there is any crack anywhere or not. Vehicle tracker, so this is a complex one. So where in the vehicle, this is an object detection, so it detects an object, boxes them and then compares with, do I have any readily available object which is comparable or matching. So that's how. And then named entity recognition, we say use RNN there to label who the person is. So if you look at this particular receiver's tracker, the speed is 30 frames per second. It captures 30 frames in 1 second and does that. You need obviously CPU, it can't run, though they have executed here. Integration, so here it is able to identify the car and say just one more, then we go into details of face recognition. The edge pose is extremely complex models that we can use. Edge pose, if you look at in particularly US, every year many millions of rupees are spent to physiotherapy, and physiotherapists are in high demand because post certain operations they need to have the so musculoskeletal disorders, so these things can be observed. So we have right now, or so far, the data is captured and then sent to some server, there it is getting processed. However, this edge pose model is able to run at a local phone level itself. It captures everything and provides the data. But what is I'm thinking of greater use to you is the face recognition of what happened exactly within this is using convolutional neural network. So this is built by Shivang, who's indoor based, who also delivers the sessions as part of this faculty development program in future. Now, so the face recognition pipeline, if you really look at an image or a video that comes in at, let's say, 30 frames per second, in that face detection happens in those frames, and then tracking, then we extract the features. We now know how to extract the features. So feature vector, you converted them into so these are only features which are vectors. Then feature matching you do with the already trained database of enrolled users. So they were there beforehand. I will share where this is being used also, and then say who is the face. Now currently this is being used in let's say people are being quarantined if they have the coronavirus. So whoever has, so they are quarantined. Now a model that Shivang has developed is through an IoT device, you can have these sanitization tunnels that are coming up where sanitization is happening. Recommendation is not to have those sanitizers at a high because that can impact the person. But yeah, those tunnels which are there, or at the entry points of malls, we can put that IoT device. So we have the data of all the people who are quarantined, and 14 days they should not be coming out. So it captures the images of the people who are coming to the mall and checks with the database if the person is supposed to be quarantined. If the person is supposed to be quarantined, immediately there will be an alarm to the mall or somewhere, or police, so that they are informed saying that this so and so person should not be outside. So what happens in this, the training of this model was a grayscale of 96 by 96 used. We took 28 by 28, here 96 by 96, and then they have created key points, so you can say filters. So 15 numbers of key points for each eyes and 5 for mouth and nose. So it is not one single one, because there are multiple filters, and then they have distilled that down to certain key filters and so on. So we need to extract 15 numbers of 96 by 96 pixels. So that is the data that they gather as an input now on the trained model. We have the details available here. I'll share this some of these slides too for understanding. Now detecting the face, so these are sophisticated models that we looked at. Object detectors. So far we are only looking at recognition, but object detection is another step that we have to use. So OpenCV, where CV2 was there, there is using this OpenCV, HAR cascade was there. HAR cascade we tested. You can recognize the face in a body, so it can detect the face, give you the data. So it's built on machine learning, there is no deep learning in it. So very effectively it works. It takes a set of pixels, a video, breaks it into certain frames. So from the video it takes frames, and that is studied, and from a picture it segregates the face. So whatever we looked at, those 15 points, that helps in identifying the face. Once you have the face, then feature extraction on the face is like this. You have a layer 0. It is exactly like our convolution. So all these 3 layers that you see are convolution layers with 5x5 convolution. 5 by 5 is the matrix, weight matrix that we have, you can notice here, and each one has different filters. Initially there are 24 filters, but then the number of filters increased by 3rd layer. Now the 4th and 5th layers are 3 by 3 convolutions with 64 filters. That's a very heavy number of filters, are quite many. And then the 3 fully connected layers beyond it. So we have not shown all of this, but if you say layer 0 and layer 1 and 2, layer 0 is the actual image, and 1, 2 and 3 are the first level. So then 4 and 5 are the next level, where 64 filters each, very deep. Then 6, 7, 8 will be a fully connected layers that we see 300. So whatever we have looked at as an example, similar one is used in this model once that object face is detected. And the final layer is with 30 nodes that they have. They are pairs for 15 key points. Finally, we are looking at those 15 key points in it. Yeah, in the Keras it's been implemented. This is TensorFlow 1. We have used a slightly different one. So batch normalization you can do. Convolution is the first layer of convolution, 24, 5, 5. So very nice that he has put everything together here. And then second one is again here, and third one is here. So fourth one and fifth one. So finally we had 5. Fourth and fifth have 64 filters, you will notice here, while the 1 and 2, 3, 1, 2, 3 and have 24, 36, 48. Now finally at the end you have 3 fully connected layers. So we can use either refer to the model at the end of this line, or you can just add to the model and model.add, and it is successively keep adding those new layers into the model, and finally you can execute the model. So this is also a easier one. We need to make sure this will run in as is in the TensorFlow 2. So then the next step is you compile the data. So RMS prop is another optimizer. So for error rectification, the last function used is mean square error. We used cross entropy for categorical. So mean square error, and metrics of course is accuracy. That's an optional. Check pointer, if you look at here, check pointer is where you will look at what is the file that we want to run, test it. So you will do the testing. Or that is check pointer is still you are compiling the data, getting the data reference, getting the input here. So we spoke about input is it is for you to run the model, we have used input and output. So then here epochs are 30 epochs, and then finally you run the model to train it. So model.fit. So you have the train data set, train input and train outputs are there. So you have the validation split. We didn't look at validation split, where within the training data set you can have a small piece of them to keep checking whether it is correct or not before you get into the testing level. So epochs, we have already defined epochs and batch size and so on. So now the model runs, and after that you can predict, you can have a predict as a function, or evaluate I used there. So to see whether the person that we are looking at is the same person or not, cross check. So this particular product or application has many different benefits if you look at, and very similar to what we have gone through as CNN. So finding the right cluster to recognize the face. So some of these slides I will share this with you. So the smart sensitization tunnel that I just spoke about, where disinfection tunnel in some form or the other, you can have an IoT device here. So this is the data from the healthcare centers, where whoever is quarantined, we have the data. That data is stored in the cloud. We just need a couple of pictures, 2 or 3 pictures of the person. So it is put on the cloud. Then through an IoT device, it is communicating here. And anybody who walks into a mall or in the public places, you can have some sort of a tunnel kind of thing, where you have the IoT device placed, a camera is placed. Through the camera the data is captured, through this internet connectivity it is sent to the cloud, and immediately we get to know if this person is supposed to be quarantined. So the same thing could be applied in the law and order situation. Say if we have any potential threat, all the busy areas could have cameras, and we could have data of people who have been antisocial or any of that nature, and easily can be captured. You can zero down very quickly to who could have been the person by looking at those images, etc. locally. So I'm sure this has very powerful applications, convolution methods, and is only increasing day by day, I would say. So I'll quickly see any questions that you might have, and so you have not got form, probably they will share with you sometime later. Can you share some BTech, MTech project problems? Yeah, you can look at Kaggle problems for now, and there are several problems that runs, you could pick that up. As feature extraction in CNN is fixed, how can we give our own features to use more important or new features into CNN? Another professor spoke about transfer learning. You can do transfer learning. So there are many questions here. Mr. Kannan Subramaniam. Feature extraction is fixed. How can we give our own features to use? So you can do a transfer learning. You can even the input itself you can change and go by pre-trained features can be input. There is a code available to incorporate that. So you can call other models data and run and build on the top of it. So can you please suggest something in identifying fire images? Fire images, any pre-trained model, I'm not familiar, I'm sorry. I'm sure we can get there would have somebody would have already studied this, and they would have some features available on fire related images. Yeah, I think we looked at it. Humble request, please share PPT. Sure ma'am, I think I will do it just after this call. Today I think the PPTs we didn't have except for this product applications we saw. I will share that. The material I will share, and two codes. You also need a CSV file. We will try and get you that CSV file also. It is quite heavy. I will check and make sure you will get it in next 1 to 2 hours while I will transfer this to Blackbucks. Alright, thank you so much for your time and patience, and I'm hoping this provided you some understanding of what the data is. So while there could be other questions, we can always connect through Blsckbuck engineers, and I will be very happy to join on a call or respond to any emails that you might have. Thank you.